Okay, so we are starting a brand new chapter. Okay, a brand new unit. Actually, it's a brand new unit. Um, this unit is pretty big. It's got like 2 chapters, but it's a pretty big unit. It's a pretty big concept. It's one of the 3 or 4 things we do. Thanks. We do in calculus. We've done 2 of them already: limits and continuity. What is a limit, and how can you tell if something's continuous or not? Right? We just did that. We took a test on that. That's 2 of the things. The other 2 things are, one of them is what we're going to talk about today. It's called the derivative. Derivative. Okay, we're going to learn all about derivatives this whole semester, really, because there's a lot we go into it. So today we're going to start with just the definition. What is a derivative? How do I find a derivative? That's all we're going to do. Okay, so so first of all, what is a derivative? Okay, so what a derivative is it's the slope of the tangent line at one point. Okay, so let me say that again. It says it right there. It gives the slope of the tangent line to a curve. The curve is the function at any point. At any point. Okay, so we know what slope is, right? We know what slope is. Slope of a line, right? Rise over run. What does it mean when I say it's tangent? I don't mean like tangent. I don't mean like sine, cosine, tangent. I don't mean that. I mean if something is tangent to something, what does that mean? See it?
Perpendicular, like a line that's perpendicular to a curve.
I've never heard that word. What? Perpendicular? Oh, okay, perpendicular. It can be. It can be, but so if something is tangent to something, it touches it, but only in one spot, right? So if something is tangent, it touches it, but only in one location. So for example, let me draw a tangent line here. It's not going to be a very good one because it's drawn by hand. But if I'm drawing a tangent line, if this line is truly tangent to that curve, it only hits it in one spot. It kind of ricochets off of it. It hits it in one spot. That's the only place that it hits the curve. That's a tangent. That's tangent. Okay? If something is tangent, it only hits it in one spot. Okay? So hits in one place or one spot. Okay? That's what tangent means. Hits in one spot. So what we're going to spend a lot of time doing is figuring out. So at this point, let's say this is at A. They're using A now. So at x equals A, the tangent of the slope of the tangent line would be the slope of this red line. So I would find the rise over run of that red line, right? It's got that line there, is that a positive line or a negative line? Or sorry, positive slope or a negative slope? Positive. Why is it positive? It's increasing, right? It's going up. It's going uphill. Anything going uphill has a positive slope. Anything going downhill has a negative slope. What is f of x doing at that point? So we know the red line's increasing, right? It's going up. What is the red line, or what, not the red line, what is f of x doing at that point? It starts to decrease a little bit, but is it going up or is it going down? At this point here. It's still increasing, right? It's still increasing. It's slowing down, right? We call that acceleration. It slows down, right? Acceleration and speed. Speed is what you're doing in the car, right? Speed is what if you're driving 40 miles an hour, it says 40, that's speed, right? Acceleration is how fast are you picking up speed, right? So we'll talk about that later in the chapter. But at this point, it's still increasing, right? I'm still increasing, right? And then I get to here, right? I get to right here. That's where I stop increasing. What would the slope of this tangent line be right here? Let me draw another color. At the blue line there. What would the slope of the blue line? It would be a horizontal line, right? Right. And then let's go further down. Let me pick a different color here. Right there. The slope of that line, the slope of the tangent line to that point there. That's negative, right? Because the function is decreasing, right? So if something has a positive slope, if something has a positive derivative, I should say, positive derivative, it's increasing. If something has a negative derivative, it's decreasing. And if something has a zero derivative, it's not doing anything. It's staying in place. Okay? You guys see derivatives all the time. If you drove to school, what it said on the speedometer, how fast you're going, that's a derivative. That's a change. All derivatives is a change over time at one specific time. So if you're driving to school and you look down at your speedometer and it says 50 miles an hour, 40 miles an hour, at that moment, that's your derivative. It's called an instantaneous rate of change, which is the same thing as a derivative. Okay? So we use derivatives all the time. We just don't realize it. Okay? It's part of the way they calculate speed. Okay? Is using derivatives. You don't realize it because you buy the car and it already does it, but that's the kind of engineering, the math that goes into creating the car, creating the programs, creating the computer. Okay? So today what we're going to do is we're going to find derivatives, but we're going to use what's called the definition of the derivative. I highlighted it right here. That's the definition. I start with the definition for a couple reasons. First reason, it looks familiar. Why does it, what looks familiar about it? Not all of it, but part of it looks familiar. What part looks familiar? Limits, right? The limit part. Yeah, it's a limit question, right? The derivative, the definition is a limits. It's a limit question, okay? So we just finished limits. So I figure that might be kind of, familiar to you, okay? So before we get into that, we're going to use a lot of symbols that mean words. Okay, in math, we use a lot of symbols. Mathematicians don't like to write sentences. They like to use symbols. So first thing is two definitions. Derivative. A derivative is a noun. It's a thing. Okay? Differentiate is the verb. That is finding the derivative. So if I say differentiate, that means find the derivative. If I said here's the derivative, that means that's the actual answer. That's the answer, the thing, right? Okay, so here are the symbols. The symbols we use a lot. F prime, that little asterisk there, that little tick mark there, we call it F prime. F prime means a derivative. So anytime you see anything prime, down here you see Y prime. Anytime you see anything prime from now on, it means that's the derivative. Okay? So the first one and the third one are the actual derivative. This guy here, let me highlight them. This guy means derivative. This guy means derivative. That means it's already been done for you. Here's the derivative. The second one, it means d over dx is the derivative of f of x with the derivative of f of x with respect to x. So anytime you see d dx, it means they want you to do something. That's an action. It's an action word. It's a command. ddx means find the derivative. Do it. Okay, anytime you see ddx, that means do it. Find the derivative. We haven't found it yet, so do it. Okay, it's a command. It's an action. Okay, The last one, dy over dx, means that's already been done. This guy kind of goes with the blue ones. This guy right here, it's already been done. Okay? So the second one is an action. D over dx means do it. Dy over dx means it's already been done. Here's the derivative. Here's the answer. Why do they use all these different letters? Well, they use these different letters. There's for derivative, especially for calculus. For calculus, we use a lot of different, there's like 2 different symbols for the same thing. They're both okay and they both work, but why? Like, why is it f prime, y prime, dy over dx? Why do they all mean the same thing? Well, it's kind of a history lesson. So the person who gets, does anyone know who the father of calculus is? Does anyone know who gets credit for inventing calculus or finding calculus? Does anyone know? Newton is the guy who gets credit for it. Sir Isaac Newton, the guy who's hit the apple, hit him on the head, and said, "Oh, that's gravity," right? He's the guy, and so what he was doing is in England, he was coming up with calculus. He was doing all the things we're doing in this class. He was developing them. Okay, he's the f prime guy, y prime guy. That's him. He's like, I use f prime and y prime. At the very, very same time, there was a guy named Frederick. I think his first name was, last name was Leibniz. Leibniz. He was in Germany. He was doing the exact same math at the exact same time. They didn't work together. I don't even know if they knew each other. But at the exact same time, they were doing the exact same math. So Leibniz didn't use f prime and y prime because he wasn't working with Newton. So what did he use for derivatives? Dy over dx. So anytime you see d over dx or dy over dx, that's a Leibniz notation. Sometimes it's called Leibniz notation. If you see a prime, that's Newton. Okay? Now, eventually they both came together, but so there's kind of a controversy over who came up with calculus. Newton is known as the father of calculus because he's more well known, right? The apple hit him on the head. He came up with gravity, the idea of gravity. So he has more attention. He gets more fame. But Leibniz was actually doing the same exact thing at the same exact time without copying him. So it's just like who developed it, who's the father of calculus, we don't really know. But that's why we have different notations. So in calculus, we have a lot of different notations for the same thing. Okay. So, but yeah, so those are the symbols first. Okay, so before we actually do a problem, so remember, when we find the derivative is not actually the slope. The derivative is only a tool that will help us get to the slope. Okay, I have the derivative, f prime, this is it. Great, that's a tool to help you get the derivative, to get the slope. Okay, so people think once I have the derivative, I'm done. Well, not if you need to find the slope. Okay, the first thing we need to do is actually just find the derivative, right? The first question says, find f prime. That's just the derivative. But if you look further, we have to find slope later, right? So sometimes you're done with the derivative, sometimes you have to use the derivative. Okay, so how are we going to use this? Well, here we go. So to find the definition, we set it up. So we're going to set it up using a limit. The limit as h approaches 0. The limit as h approaches 0. Okay. That's the first part. The second part is this part right here. F of x plus h, right? Minus f of x. That's probably the easiest part. F of x is just the original, right? F of x is just the original function. So whatever the original function is, that's what goes there. Okay? So how in the world do we do x plus h? Well, let's see. Let's go down to this. F of x. If I were to change x, right? If I were to change x and put a 2 in there, what would that 2 mean? What would that 2 mean? What would I do with that 2? It's the x value, and what would I do with it? I'd put it anywhere there was an x, right? So I put 2 here. 2 squared is 4, right? That's what we always do, right? Well, that's essentially what they're doing. They're saying, instead of x, I want you to put in this. Everywhere there's an x, I want you to put that instead of a number or x. Okay? So let's go back down here. So this is our function right here. The only place to plug in anything is right here, right? So what the definition says is the first thing I want you to do is anywhere there's an x, I want you to replace that with x plus h. Okay? That's what that means. That's what f of x plus h means. It means plug in anywhere you see an x, plug in that. Plug in x plus h. That's the first part. And we got a minus, right? Then the second part says minus the original function. Well, the original function was given to us, right? That's x squared. Okay. H is on bottom. H is always on bottom. Just an H. That's the setup there. So how do we solve limits? What did we learn last chapter? What's the first way we should always check when solving a limit? Plug and chug. So try it. Plug and chug. So what do we get? You can do it in your head or you can do it on paper. So what do I get when I plug in 0? What am I plugging in 0 for? H. Good, not x. H, right? So if I plug in 0 for h, what do I get up here? X plus 0, which is just x, right? So x squared minus x squared. What's x squared minus x squared? 0. So I get 0 on top and 0 on bottom. And what did we learn about when we got 0 over 0 anytime we got a limit? What did we always learn about that if we got plugged it in and we got 0 over 0? We have work left to do. Yeah. And that's what we have to do. We have work left to do. What work do we have left to do? Well, I see this guy here. You see this guy here? This is a binomial squared. I'm going to expand that. I'm going to expand that. Okay? So this guy over here, I'm going to expand so that I don't have that. Multiplication box, 2 by 2 multiplication box, or you can do FOIL, first, outer, inner, last. Okay? When I do that, I have like terms, right? These two guys are like terms. So it's really x squared plus 2 of these guys plus h squared. That's really what it is multiplied out. So I'm going to replace that. I'm going to rewrite the problem. So instead of h plus x plus h squared, I'm going to write the multiplied version out. Same thing, but just multiplied out, right? Can I take away my parentheses? Yeah, because what's in front, right? A 1, right? And so parentheses aren't needed. So let me take away the parentheses. Parentheses gone, parentheses gone. Combine like terms. X squared minus x squared is gone, right? So what's left? The limit as h approaches 0. Now I have 2xh plus h over h. Plug it in now. Let's see. Plug it, chug, see what you get. What do we get when we plug in 0 for h? 0 over 0 still, right? We still got work left to do. Okay, so now we're here. What can we do?
Make a GCF of H.
Yeah, they all have h's, right? This guy has an h, this guy has an h, this guy has an h. They all have h's, so I can factor out GCF, which is an h. So let me do that. Oh, sorry, this is supposed to be h squared, right? Yeah, it's supposed to be h squared over here. Sorry. Sorry, that's why it didn't seem right. So if I take out an h, it's still going to have an h. Right. Okay. Factor out. Now I can cross out that h. Now plug in 0 for h. What do I get? 2x. That is your derivative. The derivative of f of x is 2x. That's not the slope. That's the tool that will help me use the slope, but it's the derivative. It's the derivative. Okay? That's essentially what we're doing today. Finding derivatives, finding slopes using the definition. Okay? So you're going to be using this guy a lot. This guy right here, you're going to be using it a lot, quite a bit. Okay? It's not bad because we've just used limits. We just finished limits. So it should be, you should be okay with it. Okay, so let's look at example number 2 now. Let's look at example number 2. Okay, so for the function f of x equals negative 2x squared minus 7x plus 7, find the slope of the tangent line. So here's a buzzword right here. Buzz phrase, I should say. Anytime you see those words together, in your head, red alarm bells should be going off. I'm going to have to find derivative. This means find derivative. Find derivative. If you see slope of the tangent line, it means find the derivative. Sometimes they don't have the word derivative anywhere in there. They don't have any of these symbols in there, right? There's no f prime, there's no d over dx, there's no y prime, dy over dx. There's none of that, right? But they use the words slope of the tangent line. I'm going to ask you that quite a bit this semester, even next semester. What are we supposed to do? What does that mean? What do we look for? Slope of the tangent line. Find the derivative. That's what we have to do. Okay? That's our first job. If we don't have the derivative, we need to find the derivative. They've given us f. We need to find f prime. Okay, so to find f prime, we're going to use the definition. The limit as h approaches 0, h goes on the bottom. H always goes on the bottom. So how do I do the f x plus h part again? What do I do? What did I do last time? What did I do last time? X plus h? The f of x plus h? What is this telling me to do? Anytime I have parentheses, f of something in parentheses, what do I always do to the things in parentheses? f of 2, f of 3, f of 4. What do I always do with those numbers? Plug it in as the x value. This one has 2 x values, so I have to plug it in twice. Okay? So this is going to be negative 2. Here's an x value. I got to plug it in here. Minus 7. Here's another x value. Plus 7. That one did not have an x, so it doesn't go with it. Okay? That's x. That's f of x plus h. It's the same function, just instead of x's, it's got x plus h in its place. Then I had a minus, right? And then the next part was the original function, right? But the original function. I always use parentheses or brackets, especially if it's got more than one term. This guy has 3 terms, so I use, because it's minus the whole thing. It's not just minus the first term, it's minus the whole entire thing. Excuse me. So I got to distribute the negative right here. The limit as h approaches 0. And I can distribute here too. Can't distribute here. I cannot distribute there because it's got a squared. So what I have to multiply it out before I can distribute it. Okay? But we've done that already. So watch. We're going to save some time here. So here we go. Minus 7x minus 7h plus 7. And then plus 2x squared plus 7x minus 7. Anything cancels out yet? Anything cancels out? Yeah, these guys do, right? These guys are right here. Something else will cancel out too, yeah. There you go. Things will always cancel out. If you do this right, things will always cancel out this way. Okay? Okay, so what do I got so far? Let's see. The limit as h approaches 0, I have a negative 2x plus h squared. I have a minus 7h and a plus 2x squared. Right? Am I missing anything? I think that's all. Everything else canceled out, right? Okay. Plug in 0. See what you get. Plug in 0 for h. What do you get? What do we get when we plug in 0? 0 over 0, right? 0 over 0. We're going to get negative 2x squared minus 0 plus 2x squared. That's 0 on top over 0. Okay. So we got work left to do. Well, I haven't multiplied this x squared, x plus h, right? I did it earlier, so I'm not going to have to actually do the parts again. I know the answer. So the limit as h approaches 0, negative 2, my answer is up here, right here in green. That's what happens when you multiply all those guys out. So I'm just going to move it down here. X squared plus 2xh plus h squared parentheses. Okay. And then I had, what else did I have? A minus 7h and a plus 2x squared. Haven't canceled anything out yet. So even if I plug in 0 now, I would still get 0 over 0 for h. So I got to distribute the -2. So I get -2x squared minus 4xh minus 2h squared minus 7h plus 2x squared all over h. Anything canceled out? Will anything cancel out? 2x squared's good. I think that's it, right? Okay. Limit h approaches 0. -4xh minus 2h squared minus 7h over h. They all have h's, so if I plug in 0, it's going to cancel everything out. Make 0 over 0. Everything has an h. All three terms on the top, all three terms are one term on the bottom. Everything has an h. So if everything has an h, that's the problem. Let's factor out an h. So the limit as h approaches 0, I'm going to factor out an h on top. So that leaves 4x minus 2h minus 7 over h. Factor out the h, cancel it out. Plug in 0 now. What do I get? -4x minus 7. -4x minus 7, which happens to be f prime, which is f prime. That's where we stopped on the last question. On the last question, we stopped because all they wanted was f prime. This one, they didn't say anything about f prime. They actually want the slope. They actually want the slope. And where do they want the slope at? X equals 5. So what do you think I'm going to do with that x equals 5? Plug it in. Plug it in. What do you get? That's my answer there. -27. So it's got a slope of -27. So what's the function doing at x equals 5? Increasing, decreasing, staying the same. Very decreasing. Yeah. -27 is almost a vertical line. That's how steep it is, right? Go down 27 units over 1 unit. That's pretty steep. Okay. So if I was to graph this guy on Desmos or something, watch, let me show you right now. I'll show you right now. Since we're not allowed to use calculators on this chapter, but it is good when you're doing your homework. It is good always to check your answer to see if it makes sense. Does it make sense with what's going on? So let me see, Desmos. Let's see, -2x squared minus 7x plus 7. So there it is right there. Let me focus out a little bit. It's a parabola because it's a quadratic. So where was our value at? Where was x equals what? 5, right? So 5's here. So we really got to go down. Really got to go. So 5 is right here. So it's right about there. Right about there. That's almost a horizontal or vertical line, right? That's so steep, right? That is very steep. That slope right at that point right here, right at this point, where is it? Let's see, right there. Had it. Right there. At that point there, the slope of that tangent line is negative 27. Makes sense. Makes sense. It makes sense with the picture, with the answer that we got earlier. Okay. All right. Example number 3. Actually, you know what? Skip number 3. Let's do number 4 real quick. Let's do number 4 real quick. I want you to do number 4 because I think number 4 is a little easier than number 3. So do number 4 right now on your own. Wait, no. Find the slope. Don't worry about the equation part yet. We'll do that part together. So what I want you to do is find the slope. Find the slope of the tangent line at x equals 12 first. Do that first, and then I'll show you how to do the equation. Okay? Find the slope of the tangent line at x equals 12. Okay, so I did the setup. That's how you set it up first. F of x plus h minus f of x over h. Okay, so we gotta distribute here. So let me distribute the negative there. So I get the limit as x approaches 0. And then also what I'm going to do, since I have already done this twice, I'm going to multiply that out. I already know what the answer is going to be because I've done it twice. It's going to be x squared plus 2xh plus h squared minus 4. And then it's going to be minus x squared plus 4. Okay. X squareds cancel out. Plus 4 minus 4 cancel out. So I'm left with the limit as h approaches 4, or h approaches 0, for 2xh plus h squared. That's it. Wait, is that it? Yep, that's it there. Over h. All have h's. They all have h's. So factor out an h. H's cancel out. You plug in 0 for h, and you get 2x. You get f prime of x is 2x. Okay. Slope of the tangent line. So what do I got to plug in there to get slope? 12. So when I plug that in, I get 24, right? So now what we have to do, the very last thing is, they want us to find the equation of the tangent line. Okay, so remember, we have 3 forms of a line. Standard form, y-intercept, or slope-intercept form, point slope form. We got 3 of them, right? They're all written up there on the wall if you can see it. Doesn't matter which one we choose. Didn't say you have to use one over the other. But I would use the one that's easiest. I know the slope, right? So standard form, nah, because standard form's kind of the one, you never really start with standard form. You always start with slope-intercept or point slope. I would probably start with slope-intercept or point slope. I don't know the y-intercept though. I don't know what the y-intercept is. Don't know what it is. So what I could do is use point slope. Okay, so point slope is y minus the y coordinate equals the slope x minus the x coordinate. I know the slope's 24. I just found that. What's the x coordinate at that point? 12, right? 12. What's the y coordinate at that point? How do we know? How do we know what it's going to be? How do we know what y is going to be? We can figure it out. We don't know, but how can we figure it out, I should say? So I got x, I need y. How do I figure out my point? Not y is 0. Not set it equal to. You guys are getting close. If I have x, this is a point, right? 12. This is a point on the graph. X squared minus 4. 12. How do I get y? There you go. Plug it back in. Plug it into the original. Plug it into the original and see what we get. So if I plug it back in, I get f of 12 equals 12 squared minus 4 equals 140. That is y. So a point on f of x is 12, comma 140. That's my y. That is perfectly fine. That is a slope, or that is an equation of a tangent line. That's an equation. It's point slope. Sometimes they want to write it as, sometimes they'll say, or sometimes a question will be A, B, C, D, and none of them match that because they're in a different form. Well, if they're in different form, you got to distribute here. 24x minus, what is that? 240 plus 48. What is 240? 288. Add 140 to both sides. (24x minus 148). That's in slope intercept, so this is point slope. This is slope intercept. How would I take that and turn it to standard form? What's the only thing I would have to do it to standard form? What does standard form have different than any of these guys? They have x and y on the same side. So you would subtract 24 from both sides to get x and y on the same side. That's all. It doesn't matter. So I've seen this on tests before where you'll get your answer. You're like, that's my answer right there. Free response, you're done. Move on to the next question. But you'll get to A, B, C, D, E, and you're like, uh-oh, that one doesn't match one of my answers. So you have to kind of tweak it to fit. Change it to slope intercept. Change it to standard form. Do one of those things. Okay, do one of those things. Okay? All right, so we got about 5 minutes. We have one more problem we need to do in the notes, and then so what I'll do is on Monday, we'll finish this question, and then I'll give you the rest of the time to do the work to do your assignment. Okay? All right, so no new assignments.